Check out this finished part. It's looking so nice here. Let's zoom in here and we'll give it the fingernail test to check the fit. And that is really good. Barely any catch right there. Really, really happy with the way this turned out. Good afternoon, everyone. I am so excited about today's video. I've been working on this process for quite some time, and I've been perfecting it, honing it. I think we're finally at a point in time and development of this process where it's ready to make our finalized parts and share it with the world. So to answer the question in the title, yes, you can mill out custom shapes, accurate shapes out of aluminum using mostly woodworking tools and 3D printed tooling to assist. So, this process is very involved, so I apologize in advance for the length in this video. I've worked a long time on this, and there's a lot of mistakes you can make if you're not careful, and you can waste material. So, I want to walk you through step by step and explain the major pitfalls, so it's going to take some time. However, at the end of this, the end goal is that you're going to be capable of milling accurate, unique, custom shapes in aluminum. Alright, so we're going to talk over a couple of little basics, and then we're going to jump straight into the first and most important part of the process, which is getting your correct dimensions. So let's go over some basics, and then we'll get right into it. Alright, so right here is one of the good faces on one of the prototype parts. So this is a really good surface finish and very good accuracy for working with hand tools and printed tooling. So the whole rest of this part has some mistakes, and we'll explain that as we go, but the mistakes are really easy to avoid as long as you follow the process here. So here's just a nice close-up example of what you can achieve if you take your time and you plan this through. I'm sure you could get better results on a real CNC, you know, or with a Bridgeport. But we don't have that kind of money here. This is the shipping container garage. We're working in a shipping container in a horse barn, so we're doing the best we can. And I'd say we're doing a pretty good job. So let's talk through the 3D printed tooling. Alright, if you've been following this project, you know I'm putting a Subaru Flat 6 into my Volkswagen. 3 ports on one side, 3 ports on the other. They're a nice big oval shape. Oval shape's hard to make. This guy won't fit in the engine bay very well. So I would have to do a whole lot of cutting of the body to make this fit. So we're going to do ITBs. Alright, so these are the ITBs we're going to be using. These are Wave Runner 1100 ITBs. These are out of a jet ski. They have a 42mm diameter throttle body, which is the same equivalent diameter as the oval shape over there. Now, these guys can be split apart, spaced, resized. These are fantastic little ITBs. They're super low profile and light. These are awesome. So we need to make a round shape to an oval shape. I've got an awesome video describing how to use 3D printed press tooling and the good old handy dandy bench vise to make this shape here. So that's a whole different video for another topic. If you haven't watched that one, please go check it out. So we need this to do what that does, and in order to bolt the intakes to the engine, we need a nice smooth transition like that, and we need to stick it in an intake manifold like so. Bam, there we go, something like that. You can braze copper to aluminum. You just have to use the correct brazing compound and the correct process. This is a smaller prototype part, same idea. Oval on one side, round on the other. So this guy is another test piece. So as far as 3D printed tooling, in order to accomplish that special milled out shape, we're using a large jig that will get bolted down to the plate. There, and there. Now these have 1/4-20 nuts stuck in them, but on the other side, this is like an 8 or a 9 millimeter diameter for the metric thread on the engine. Now, this is one half of the equation. You need this fixture plate. See these holes? These holes are going to line up with a milling jig. I'll show you that next. Here's the milling jig. See, it's got the matched holes there, so that this guy will set down in. I'm not going to be able to do this one-handed with holding the camera. That guy locks in, and it gets through bolted through there, and you clamp it down. Once you drill these 4 holes in the aluminum and lock this guy in, you do not want to remove this. You want this guy locked in space because you want all these dimensions to line up. So the idea is you set your milling jig on here, and this milling jig is equipped with different cut operation tools. So these ones are similar, but they're all different. This is insert 1.5, this is insert 1.0. The core component for milling aluminum with a router is that you take very, very small cuts. The smaller the cut, the better. It increases your tool life, doesn't get hot, doesn't melt the aluminum, doesn't melt the plastic. You want to go nice and slow and take tiny cuts. So this jig is equipped with you'd almost call this like a tongue and a groove type or a dovetail type joint here. So these cards will slide in and out, and it's going to sit in there like a so. This guy will line up on the aluminum part. You'll take your drill press, or I suppose you could, if you're very careful, you could use a hand drill. Drill out all those holes. And then same deal for the next guy. These are slightly offset holes. These ones will set the, what do you call it? Basically the bridge between the two holes. This sets the holes on top of them, so you drill those out. That way you're going to have a shape that looks, let's see, do we have one? No, we don't have a prototype with one. But basically it's close to the final shape. Once you're there, you'll take one of these two, you'll set it in there, and the idea is you will set the router on top here, and you will use the not cutting edge of the tool, right, the nice round shank that's not going to cut your plastic, and that's going to be your guide, and your router is going to, woo, there she goes. Your router is going to follow this guide like a so, bam, like that, all the way around. And it's going to take tiny, tiny cuts of that perimeter. Now you need to take very small depth cuts. You need a lot of oil, and you need to monitor the heat of the whole system. So you got to be careful. Routers are, you know, a slightly dangerous tool, and I'm not an excellent router instructor. So if you see me doing something dumb, call it out in the comments so that other people do not make dumb mistakes. I don't want to see anyone getting hurt doing this. So with this thing being locked in the plastic jig, all the cutting is happening well away from the user's hands, right? It's going to be deep in this jig here. So I think it's a pretty safe process, but don't take my word for it. Follow all, you know, manufacturer safety precautions. Do your due diligence. Do this right. So that's basically the long and short of it. For my specific part here, on this prototype here, I used about a 3/16 depth on a shoulder there. So this guy's going to set in there, get itself locked in, and then we're going to fill in all these gaps with that brazing compound. And then later on we're going to make a top plate to work with that mating flange and this whole mating system. But we're not there yet. First we're going to make the more complex part. Alright, I think we're at a point where you understand the basics of the process, and like I said at the intro, there's a lot of pitfalls, and I'm going to do my absolute best to walk you through a step-by-step and teach you the safe way to do this, the correct way to do this, the quickest way to do this, so let's get right into it. Alright, so for any good milling project, the first step is going to be to figure out the dimensions of what you need to cut and where it is, how big it is. So we use a tester piece here, and well, shoot, that ain't gonna fly. Alright, so step 2 is figure out the dimensions that you need. Well, that ain't right. Okay, step 3. Figure out the dimensions for the holes and slots you need to cut. Well, that ain't right either. Step 4. Figure out the correct dimensions for the holes and slots you need. Gosh darn it. Still not right. Step 27. Figure out the correct dimensions for the holes you need to cut. There we go. That's the one we want. This is what we need. We need these ovals and these holes in this location. Now, I don't have a big enough set of calipers or a better measurement tool that can measure from there to there. And it's really a tight, cramped, compact space. This is not an easy thing to measure. What I did to get close and start the process is I took the intake manifold, the plastic intake manifold, and I laid it on a large scanner bed, and I scanned it like you would scan a photo, and then I scaled the image and did my best to draw dimensions on top of that. That got pretty close. That got close enough to where I could take one of these plates here, I could lock it in with one hole, and I could write down notes on what to move and where. And these are measurements in millimeters. So I was able to do an iterative process to get closer and closer and closer to the final size. So when you're doing something like this, the 3D printer is great because these guys print in like an hour or less if you print them thin like that. Don't leave them out laying in the warm shipping container though, because they don't like that. All right. So this is going to be a trick to try and get her lined up while holding the camera. There we go. This is going to be as good as I can get it. So I'm pretty proud of that. Okay, this is the shape we need to make in aluminum. Okay, we need ovals that are this size, and we need ovals in this location, and we need holes this size. Okay, so we switched over to the GoPro, stuck onto the drill press here. So first thing to mention, so as you saw previously, I can make these intake flange plates basically. So this is the end result of what we want. However, this is printing out a diagonal on my printer, and my printer was absolutely maxed out. I can't print something with, I had to print this at an angle like that, so I can't print something with these edges sticking out. So this had to be a two-part piece. Depending on what you're trying to do, you may not have to do a multi-part assembly. Hopefully you don't. It sucks to do multi-part assemblies. This guy has that similar kind of dovetail shape and a through hole to bolt them together. Now, you don't want to just bolt them straight together willy-nilly. What you want to do is you want to take your jig plate and you want to line up your embossments sticking out that mate with this guy. You want to lock this guy in with this guy and then bolt your two bolts together. This will help take out any inconsistency in this joint. You don't want to be relying on just that printed joint. You want the multi-piece assembly to do its best job of centering everything up. So we've got that guy in, okay, and it's locked down. Now, well, so it's not bolted down, but it's doing its job. It's tight enough. Now, what we're gonna do, we're lining this guy up here. We are gonna drill this hole. While we're drilling that hole, we're gonna make sure that this side is clamped down. Now we have some margins on the edge of the part here. I mean, you can see down here. There's a little bit of space there, and there's a similar size gap on the other side. So we have some room to work with. It doesn't matter too much if this guy gets out of whack, right? It doesn't matter if this part is the base material is square in the jig. All that matters is that the jig is locked down, because as long as the jig is square and true to itself, that's all we care about. So we're drilling that one. We're gonna lock this guy down, and then I have a special trick to center this thing up and lock it in. So Let's time lapse this. We'll get through the drilling process, and then we'll talk through the rest. Okay, so now we got the first hole done, so we need to clean out the chips from the walls of this thing, and we need to set a bolt in, or a nut in there and bolt this guy down now. So a critical thing we need to do, we need to make sure that that hole is lined up with the plastic and the aluminum there. So the clamp over here has done a good job of holding it straight. However, we're going to use, ooh, get out of there. We're going to use a 7/32 1/4" long socket because the outer diameter, oh man, it's so tight. I don't know if you can see that. That is so close. So this is going to be our tool to tell us whether or not we're centered. And we're going to use this to align it on the other side. So we're good. We're in good shape. Hole is nice and lined up, nice and straight. Set a nut in there. All the way in, and we're going to bolt it from the underside. Alright, so we're in good shape again. So as you can see, I took a pair of vice grips to clamp this down with a very gentle clamping force. You got to be real careful with a clamp like this because this thing wants it to pull a little bit in the lateral direction, which we don't want. So I think you saw in case you didn't, I stuck the drill bit down into the workpiece and used the drill bit as a method to lock the plate into place while I engage the light clamping force. Ooh, marred it a little bit, but that's going to be alright. That's not a locating surface. As long as it's not sticking up, it's not going to cause a problem. But that's what you get. That'll happen. Okay. Use our handy dandy aligner tool. Ooh, look at that, nice and tight. Looks like we're a slight bit flexed out of place. So we're going to use this tool, align it like that, and then we're going to go back to our copper clamp. Clamp it in place, set a nut in, bolt it down. Now this might induce a tiny bit of angle error across the thing, but I'm not too worried about it. It was only a tiny bit off. If we do end up with something like that, we can always just make the hole size a tad bigger to account and allow the plate to flex. Alright, so we got the holes drilled, we got this jig locked in place, and I just tested all holes are aligning, so we're in good shape. So we're going to start over here, and we're going to start with the drilling process. Before we do, let's talk a little bit about this jig. So these hole diameters have a given tolerance on them. You know, the hole has to be a tiny bit larger than that. My 3D printer prints outer diameters different than it does inner diameters, and this is just something I had to learn over time. So I don't feel comfortable giving you, the user, a tolerance for hole location like this. That's something you're gonna have to figure out on your own, unfortunately. So yeah, I wish I could just say, you know, just add 3/1000ths to the hole diameter, but it's gonna be dependent on your specific 3D printer. So you'll have to figure that out. The other thing that you'll probably also have to figure out is the clearance required to allow these guys to fit comfortably. So this needs to be snug, but it shouldn't be to the point where you have to use a hammer to hammer that thing in, you know, and you got to be able to yank this thing out. So I gave this guy a handle to pull this out. So that's been working out really well. I really like that handle. It doesn't take a lot of force, and it doesn't try to yank this thing off of here when it's bolted down. A couple things I wish I would have changed. So the first thing I did, I attempted to use square pegs to secure the card into the slot here. So that square peg lines up all the way down into the card, right? Oops, sorry. So that works out okay. However, it's quite the trick to get the peg out when it's locked in on the jig here. And especially over here, I didn't do my due diligence and plan ahead. This square embossment covers that guy completely. So the square peg was an okay idea. Just, you know, you learn as you go and you make changes when you find stuff that doesn't work. So in order to get around that, I just use a good old-fashioned basic wood clamp, and I wood clamp the jig in place like so. Okay, that works all right. Actually, sorry, I clamp from down back here, not up top, because I need this work surface. So if I was going to do it again, I would plan that out and give this guy a surface to clamp to. For this guy, I made these supports coming off the base here so that this plate doesn't want to flex when the router's on it. This is like a 0.3 inch thick plate. I don't think it would flex anyway. It was just kind of an insurance policy. That's just the way it lined up. The other thing, do you see how the card here has a slot through here, and the head of the bolt, okay, head of the bolt drops in like that. So it's clearanced appropriately for there, but if you want to undo this guy while the card is still in here, it's gonna rub on the edge of the card. Let me see if I can find one of the prototypes. Yeah, this guy. I don't know if you can see it, but right there it marred up the surface as it was backing out. That's just me not doing my due diligence and thinking through all the clearancing problems, right? As this guy rises, right, it's gonna impinge in that space right there that the card needs to slide through. So if I were gonna do that again, I would probably try and modify that location a little bit. Now, what I would love to change, and this is like a 15-hour print, I don't want to print it again. I would love to add holes to the back of this guy. Doesn't even have to be round holes, just square holes, any holes, so that I can better clean out the aluminum shavings that get in there. So I can use the air compressor and just blast, and it does a pretty good job, but I constantly find myself using a tool like the chisel here to go all the way in there to the back to knock free the little chunks that get pressed in. So that's just really annoying. I really wish I had done a better job there. Overall, I'm very happy with this tool. Now, this tool needs to be adequate. It needs to have enough surface area as a work surface so that the router jig has plenty of space to do what it needs to do. In my very early prototyping, I used a small jig like this guy, and this just had too much potential to wobble and walk around. So you want a nice big surface. You don't want it to flex. Oh, very important. So let me throw the slot jig into here. You want to make your tool holder jig obviously larger than the part you need to cut. This is so that these cutting teeth don't tear it up down here. You don't want those cutting teeth to get anywhere near that edge. Okay, you also need to do your due diligence on the size of the bit that you order relative to the size of the jig you're going to use and the size of the depth in aluminum that you're going to cut. And this all has to coordinate with the total thickness of this, right? That you need to be able to get deep enough to do the work you need to do, right? So you need to do a lot of thinking ahead and a lot of planning. And this specific tool, I think it's a 4-inch long. It's an awesome tin coated 3-flute 1/4-inch end mill. This is an awesome tool. It has held up incredibly well. Now this is a center cutting bit, a center cutting mill, and we're going to use that to do a couple center cuts. It's very important that you find a mill that can do a center cut. I believe I have a little 1/4-inch mill that would be a useful tool. However, you just have to be aware of its limitations. It is. I'm almost certain this one is not a center cutting end mill. It's a short little guy. It's a little 4-flute. This might do a center cut. I don't know if your GoPro is going to be able to see, but basically these two teeth coming across here, I don't know if there's enough material to actually wick material away when it's plunge cutting. So make sure you got a nice tooth coming all the way across the front there, all the way across the middle there, to make sure that it's going to cut what you want it to cut. So if you look real close, this tooth is longer than the other tooth, and that's because it's cutting across the middle there and doing a center cut. Alright, so we have some drilling press operations here. We're going to be using card number 1 and 1.5. These guys are the, I mentioned it earlier, but these are the offset hole patterns so that you mill the bridge of the previous cut. Alright, so let's get to it. Bolt the jig down. Start with drill press op number 1. Oh, we're going to use a 1/4-inch drill bit. However, these holes, most likely due to my specific printer and its inconsistencies, these are .255 holes. And if you look close, you can see some of the plastic that gets removed. It's just like these wafer thin scrapes off the side there. That's just because the printer is imperfect. It's never going to make an exactly perfect hole. So you need to clear out the hole. I just clear by hand, spin this by hand, and just peck in through it. And that's the way I clean out my holes for the drill press op. So let's get her set up and get moving. Alright guys, so I need to talk you through a couple very important items. So first, the keen of eye will have seen that these are printed plastic threads on these embossments. Now, that works fine. You can do that. However, what I like to do before I do any work is I take a 1/4-20 tap and I very gently clean out the threads in these holes. You'll remove a tiny amount of plastic as you do that. And that's going to help you because you want those threads to be as close to exact as possible. And when you're torquing this down, you need to remember that these are plastic threads, and if you torque the crap out of them, you will break them. So you can do this, and it'll save you time. Just be aware of what you're working with. Now, the second very important item to discuss is drilling depth. Okay? My first prototype, I hate showing this because this looks like crap. My first prototype, I through drilled all the holes. Okay? And that's not what you want to do. You want to drill to just a hair above the final depth. Now, what that'll allow you to do is you can fill this whole trough with oil. You really, really need to have lubrication in these holes here for that router bit. The router is made for really high RPM cutting wood, right? This is like 30,000 something RPMs if I remember right. That's way too much. You don't want to be destroying your bit, destroying your lumen with high RPM and no coolant. So when you have through holes, your coolant will just fall straight through, and you have to constantly stop, spray more coolant or oil into the hole, and it just makes a ginormous mess. Now this guy, second prototype, you know what, I'll explain the failures in a moment. These things look awful and I apologize. Second prototype, the holes are at appropriate depth. Alright, now this guy, you see this big old cut here? This is me being a little too excited. I forgot to clamp down the jig. The jig, the card slid out, and so it started cutting over there. If you take really large cuts, the cut direction of the mill actually can make this height set jig slide because it's pulling itself in as it's cutting, and it's pulling with quite a lot of force, so it sucks itself down and in. And so if you look closely here, you'll see that this guy actually ramps downward. So I've done a couple things. I've taken some of this red duct tape here, and I stuck it on the outside surface, took the tape off. It left a very sticky residue, and that's actually made this thing have some friction to it. The second thing you need to check, you need to make sure the lock nut is actually allowing it to lock tight, right? And you'll be surprised. I mean, I can take a hammer to this, tap, tap, tap. This guy won't move, but the high frequency vibration and the cutting tool sucking down will make the depth set change. You also need to make absolutely certain that you lock down this lock nut as tight as you can get it, because that's another source. This guy can pull out of the collet, especially if there's any errant chunks of aluminum that got on the surface of the collet between the collet and the bit and the mill. So you need to really watch yourself on this. Okay, so my drill press has a depth gauge on the side. So I simply check where my depth is. See, I just, with the tool off, I'm just touching the aluminum. So, you know, come down 0.45 inches, 0.47 inches, somewhere in that range. You don't want to be too thin to where it's like you breathe on it and it'll break, but you want to be close. So if you don't have a depth set gauge like mine does, what you can do is you can come over. I'll try and position this so you can see here. We'll bring that guy down. So I'm kind of working on the back side of my tool, but I'm trying to show you, the viewer. So you can eyeball, and you can look and say, okay, that's about 30 thousandths or so. And you take your piece of tape like so, and you wrap it around the bit like this. Now what that's going to do for you, when this guy spins around, as soon as the tape starts hitting this plastic, you can see it deflect. When you see that tape deflect, you know you're at depth. This is how you can set your depth without a fancy depth gauge on your drill press. You can do this with a hand drill as well. So I'm sorry if some of this seems, you know, real basic to some of you, and you know you're really smart on this already. That's okay. I'm doing my best to teach people that are kind of like my age that don't have tons of shop experience. So apologies if this seems basic, but that's just the way it's gonna be. So alright, we're gonna stick the number 1 drilling card in here, and we're gonna switch over to 1/4 inch bit, clamp this guy down. It's bolted, it's all bolted. We are ready to start our mill drill process. We got the card out, we got this guy cleaned up, and looks good. The only thing I could say is that one over there has a pretty big bridge. So, the key to cutting out bridges is you don't try to do it with a drill bit. If you try to do it with a drill bit, it will pick one of these holes and it will walk into it, and you will miss your mark. Now, that's what happened. There, and a little bit right there. I was just testing on this workpiece, right? So I was trying to do the drill bit to drill out the bridge, and it gouged it and walked it to the side. That's not what you want. So you can use an end mill in a drill press if you're very careful, and you're only doing drilling operations if this is a center cut mill. Right, we talked about that a good amount before. The drill press quill doesn't have the bearings to support a side load. You can't do the milling op in a drill press. So for this guy, you want to minimize deflection as much as possible. So deflection comes easiest when something is very long. So if I left this guy the full 4-inch length sticking out the bottom, you know, with only a 1/2 inch or so, that's a lot of capability to flex. But if you have it clamped a lot closer, it doesn't want to flex as much. So if you're going to do this with a mill, you need to do slow little pecking operations. Now when I watch on my depth gauge over there, I'm doing like a 32nd each pass. Just slowly work my way down little by little by little. Same as with the drill op, you need to add plenty of oil. So beyond that, it's nothing too different. So we use the second card, stick it in, clamp it in. Now I liked, if you were giving it a real keen eye on the time lapse there, you would probably see that I was starting the drill while the bit was in the jig. That's alright, as long as you do a good job centering everything up and making sure everything's square and straight. Now, you just need to make sure, especially with the mill, that your cutting teeth are not in the jig. Okay? And so you're going to have to do the same thing with a printed tool. You're going to have to do this up and down motion to clean out the imperfections of the hole to make it round. So other than that, it's pretty straightforward, just like before. So let's time lapse it and get through it. Alright, so it's important to talk about what we just did. So this is a mistake that you, I hope, at home don't have to make. So when I was checking my depth set, I was looking at the height offset of this to that, but I didn't realize that this guy was going to be in danger of catching the plastic. So the 3 triangular chuck pieces ended up engaging the plastic right there and stopped the work there. So we've only made it about a 1/4 inch deep, so we need to drop this guy a little bit more, reset all the heights, and go from there. Alright, so we've knocked out a few of them. I want to film this one live. You cannot use enough tap magic in this process, so okay. I spin it as I'm dropping it in to help it align after putting that oil on. Alright. And I use my depth set tool up there, and I see I'm at the 1 inch mark. So I just need to go down to the 1/2 inch mark. Now, something that's worth noting, the drill bit makes a cone-shaped hole, right? So if it's from knuckle to knuckle is a 1/4 inch, as you get deeper and deeper and deeper, your end mill starts cutting away more and more material off of that underside of that triangle that cone shape of the drill bit's leaving. So when you get to the very bottom here, I don't know if you'll be able to hear it, but I can hear and feel the cutting tool is working harder as it's going deeper. So I just slow down and just give it real easy pressure as I'm dropping it in. So I find that 0 point, I come back up a little bit, start the tool, and I'm clamping with a good amount of force. If you try to take huge cuts with this thing is gonna flex. It's gonna put that torque into jiggling this guy around, and it'll freak you out. So you got to be real careful. Take tiny cuts. Hold this guy down, okay? And if something does go awry, don't just let go of the thing and yank it out, because this thing could catch on the plastic, could catch on the teeth and start walking around on you and shaking everything to death. You don't want to do that. You want to be firm and steady, even if it's getting wonky. If this thing goes wild, just let go, get away from the machine, unplug it, whatever, right? If it's not going wild, but you just hear something you don't like, just back the tool up a bit, shut it off, and reassess. Go from there. Okay, so we're gonna add a little bit more oil just in case. Find the bottom, back it off, start the tool, clamp down tight. Small picks. You really don't need to remove a lot of material. This is a patient, slow job. We're getting close. Hear how it's not chattering as much? And we're there. When you get to that bottom of that cone shape, it starts engaging the tool better, and it has a lot less chatter. I like to back it out as I'm walking up, because there's a good amount of chips that are always on the bit, and so if you just drag it straight through, it's going to catch on the plastic. Then I put the rag on it, use the unthreading direction, which pulls the rag down and it cleans that thing off. And that's how you do one. Walk over to the next guy, carefully line her up, oil it up, set the depth, repeat. This can be a pretty quick process if you get this this down, and having that depth set tool is awesome. Really, really helpful. Alright, so just keep working at it. Dang, look at that. How's this for getting the depth right, huh? We need those to stay intact. We need the oil to sit in here. Alright, so here she is. Drilled and end milled. Now I'm a little worried about that one right there. I think the drill bit may have walked right there. Just a little bit. Okay, let's stick this guy. So this is our milling op. If we try to line the camera up with the edge and walk it around, I don't know, it's close. So this hole pattern is not, the wall of the hole that's cut is not exact with the wall of the finished part. It's set inwards by, I think, 0.025 or 0.03 or something like that. enough to allow some wiggle room, so the mill is still doing some of the work. So yeah, I'm gonna set up the little GoPro on a stand so I can work with two hands, and then we'll talk through the router stuff. All right, let's go. Okay, so some important items to discuss. I stuck my oil jug into the deep freezer because we need to keep this as cool as possible, okay? So that's probably like somewhere between 0 Fahrenheit and 32 Fahrenheit. So it's going to be nice and thick and sloggy, but that's okay. So this whole process is going to be an oily mess, so don't wear your favorite clothes. All right? So nothing really to it. I just add enough. Ooh, look at that. It's like honey. Oh man, that came out way faster than I wanted it to. So you need to add enough oil so that the surface around the holes is covered up. And we're going to be taking depth of cuts that are about 1/16 of an inch. So you need some oil above the surface so that it has something to work with, right? If it's only in the pocket, well, it's not really going to do anything. The second most important thing you can do here, bring an illustrative set of old cards. This surface that the end mill bit is going to ride on needs to be constantly lubricated. Now the cool thing with this having this step, this little shoulder, you can pour oil along that top edge there and it will constantly drip down. We'll see if it wants to do that with the thicker, yeah, it still's got some flow. It's just not wanting to flow a lot. With this thicker cold oil, yeah, it's still flowing down. Basically, you want as much oil as you can get ready to lubricate this surface, and in a second here I will show you why. Okay. If that router bit or that end mill bit gets hot, it will very quickly melt through the plastic. It needs to have a thin film of oil. When I did this one, I think I like totally forgot to add oil, and it didn't take long at all. This guy as well had a couple little holes as well. This is a number 2. The left hand is also oh, both are number 2s. Yeah, so you really need to be mindful of that, and you can feel it if it starts to dig into the plastic. Luckily, these are cheap, easy parts. You can print these guys no problem if you do screw one of these up. However, if you do screw up like that, this is what happens. This guy right here, that was this one. Let's see if we can line them up. Yeah, right about there. I don't know how closely you can see with that little GoPro, but this is pretty much, oh, sorry. This is pretty much exactly where that thing started going awry. So you gotta watch for that. Very important. Lubricate these cards. If you don't, you'll blow up your plastic and you'll ruin your slot you're trying to make, and you'll have to start over. Now, so remember, this hole that I'm attempting to make has a major diameter that goes through the entire thing. Then it has a larger diameter step for this shoulder here. Now, if you jump straight to cutting this big step shoulder, you're cutting an extra, you know, about 1/16 of an inch of material each pass. So do this hole first, do the smaller hole first, because it lines up better with the drilled holes that we already made. You're just kind of gonna have to take my word for it. Unfortunately, I don't think I have an illustrative way to show that, other than you're gonna be cutting less material on that that step if you do the smaller hole first. All right, so we talked about lubricating this surface. Needs to be good and oily. And we talked about how there needs to be a lot of oil down in the trough here. What I like to do after I do each pass is I take my finger and I check the heat up here, which is where the router bit is running on the plastic. if you feel it starting to get warm, you need to take a break or find some way to cool it, like very cold oil. The key is not letting heat get to the plastic. It's not the end of the world if the end of the router bit has a tiny bit of heat. It's okay if that's a little bit warm, because as soon as you stick it in the fresh oil, it's going to cool down. Now, what I do between passes is I take the vacuum and I suck all of it out. So I'm using a vacuum I don't care about. It's just the way it is. If you do a good job with your jig below and your jig above and clamp it tight, the oil will sit in that pocket and it doesn't spill out the sides. And if you're taking these 1/16 inch depth cut passes, it makes some really tiny flakes, and with that oil bath, the flakes of aluminum stay in the oil and they don't go everywhere. If you don't have adequate oil, you're going to get aluminum chips everywhere. So it's not the end of the world, but you know, that's what it is. So okay, so when I want to be consistent with setting my depth, I start by undoing the tool, and I will set it in the very middle where there's no holes. Right there, this is my 0. Okay? I'm not cutting anything if I follow the path around. Now, this guy, this is one of the early intake plates that I was testing dimensions on. You can use this as a height setting tool. So what I do, take the tool out and I set it on top of here, unlock the tool, let it drop down onto the aluminum, and if you push downward on the height set tool, watch what it'll do. It'll force it to square up, and you can lock it in. Oop, I might have moved it there. Once you lock it in, take that away, and you can check by setting it on that big flat spot, and look at that. We're not taking a big depth of cut. Alright, so I mentioned it earlier on, but you need to make absolutely certain that this guy is clamped down really tight. You need to make absolutely certain that this guy is also tight. So we're going to run through that, and then we're going to time-lapse this. Maybe we'll film the first pass just so you can hear what it's like. It's a loud process, but thankfully with this router base covering up like most of the material, this is actually a pretty clean process. The dirtiest process is oiling up this surface that the router bit's got to ride on. But yeah, there we go. Alright, so my apologies, we almost forgot a very critical step. So here's one of the chunks from the center of the one I already cut. See how there's a big old 1/2 inch hole in the middle? And then there's this crappy sloped hole where my thumb is. Okay, you need to mill out or drill out a starting point for your end mill bit. So I use a 1/2 inch drill and I just drill right in the, not quite in the exact center. Not there. If I go there, it'll walk. But we want to be a little bit there. We need a tiny wall thickness for the end mill to break through. Not a lot. Yeah, that's getting closer. That's probably about where we want. Something about 30 to 50 thousandths thickness. Now something to watch for. Okay, so my drill bits have this triangle cut on the reduced shank, which is nice. However, I discovered that this one, this specific bit, goes a little out of square when you jig it on the triangle cuts. Now I'm not sure if that's coming through on the video. I can see it in person. I can see the wobble. Okay, so we don't want that. So I chucked this up on the outside edge and it's way straighter. So you got to clamp the chuck really, really tight because you don't want this guy loosening and spinning on you. So let's re-chuck that. Alright, so it's re-chucked. I don't know if you'll be able to see it, but I can see it on with my eye. This thing doesn't wobble nearly as much. Okay, so you got to follow the same depth setting procedures. You don't want to drill deeper and crash through the material because we need that pocket of oil. So without further ado, let's set this up and drill this thing. Alright, so I'm not sure if I gave a good enough explanation of why we need that 1/2-inch hole. So while the jig table is off the tool here, we're going to explain what I meant a little better. So I'm hoping you can see in here. So you're going to start your cut, you're going to turn your tool on while it is sitting somewhere in this hole. And then you're going to send your tool straight that way, cut through the wall, and kind of make a little channel so that you can always get through it. And you'll run into the wall here, and then you'll start your path going around here. Now, I always do a clockwise path. Now, there's a name for the cutting tool rotation direction. I've found that a clockwise path with a clockwise turning bit is working best. And I think what that's doing is the teeth are grabbing the material and it's pulling itself in. Whereas if it's cutting a right direction of bit and then a left direction of that, it's going to be cutting into the material, and the leading edge of the tooth is going to try and kick back and out rather than get sucked in tighter. So you need to follow that right hand path all the way around. Yeah, so that's the purpose of that 1/2-inch hole. So we got the same problem though with the cone shape at the bottom of the hole, but we'll get to that when we get there. Basically what you're going to do is you're going to your tool's not going to set to the depth because the cone shape at the bottom of the hole doesn't allow you to. So you have to actually start up and out of the material, turn the tool on, and then set the tool in. It'll make sense once we get to that point. So I think now we're at the point where we're ready to mill the aluminum. And so since this is the smaller oval, we're not going to go all the way through because we still have to come back and do the outer perimeter for the shelf. So let's jump right into it. Alright, so we're going to set our height on the uncut portion. So we hit the flat surface, push the plate down, the height setting tool, gently lock it in. There we go. That's what it should feel like when we're at a 1/16 inch of depth. So we're going to go set it into the 1/2-inch hole. And we're going to go this way, that way, till we find the middle. That way, till we find the middle. Now we're at a stage where we can turn the tool on. So we're taking a 1/16 inch cut, and we're going to go nice and easy. And I'm going to try and hold the tool from here. If you hold the tool from the top and you push downward pressure, you run the risk of pushing it through the height set. So we don't want that. I have my speed setting at about 5 on the dial there. That's what I found works well for me. Now, let's see, anything else I need to talk about? Just remember, when you're cutting through this hole this way, don't just make a single pass. You got to make a little channel so that it's easier each time you go through. You don't want to be trying to find that 1/4 inch wide slot that you made when you're at a 1/2 inch of depth, because you're going to be running into 1/2 inch walls trying to do it. So you want to make it easy for yourself to find that path. And you're going to be able to feel the difference in resistance while you're pushing into the material if you're hitting a thick wall or just passing through that 1/16 inch of depth. So without further ado, let's get her started. Alright, we've got our favorite gas station safety glasses on. We double, triple, quadruple checked that there's oil on the running surface. We centered it. Now we're ready to fire up. Oh, after we plug it in, of course. And since we're doing that, important time to remind everyone, take your tool out of the workpiece when you plug it in on the off chance that this thing is switched on. Alright, 1/2 inch hole, find the middle of it, right about there, let her rip. Okay, I don't think you'd be able to hear me over the sound of that guy, but that was us breaking through that 1/2-inch hole wall and finding the, getting ready to find the edge of the plastic, and we're gonna follow that plastic around. So we're gonna start her back up. Okay, another thing to remember, you always turn the tool off before you move it or remove it. Alright, not too shabby. Now it looks like an awful mess because, well, it is. It's aerated oil with aluminum shavings in it. So we clean it out and we'll take a look. Alright, let's see if we can bring this stand a little closer here. Okay, well, it is going according to plan. Let me get a pointing tool so you can see here. This is what I was talking about breaking through. We broke through a little bit more than we needed to, but that's actually alright. That's not going to hurt us. And we did a good job of making sure this running surface is lubricated. And when we go add more oil to the pocket here, we're going to add more oil to the running surface every single time. And while we're thinking about it, check the router there. Check the bit. Bit is not warm. Barely warm to touch, if anything. So we're good there. So let me walk you through the process to set the depth on the next pass, and then we'll, once we get that figured out, we're just going to time-lapse this thing and let it rip. Okay, so when we did the first depth set, we used the uncut flat surface, but now we need to use the cut flat surface. Right? If we set it on the uncut and we try to set our depth, well, that's not going to work. We got to use the surface that we just cut. So find that flat surface. It's right there. See how there's a tiny little bit of height offset, a little bit of wiggle there? That's what we want. So we take our spacer tool, unlock this guy, drop it down so that it's touching that surface that we just cut. Set it on top. Hey, that looks like the same 1/16 inch of depth that we saw before. Now if we hop up onto the totally uncut surface, you can see what an 1/8 inch looks like. That's a lot of cut. We don't want that much. Okay, so set it there. We're happy. Add oil to the pocket, add oil to the running surface, and then we let it rip. Alright, so that should have been 5/16 in depth. Do you see how this shoulder that we just did is now getting really close to the same height as the edge of the wall of the 1/2 inch hole? So our starting area is getting smaller and smaller, and you can feel that. I don't know if we'll be able to find an angle to show it. Basically, you can feel this thing getting hung up. So I'm up at the edge of the 1/2 inch hole right there. If I go to the middle, it's still got a little bit of wobble. So the way we solve that is we turn the tool, so we find the center. Whoop, sorry. So we find the exact center as best we can. We will pull the tool off like this, turn it on. Once it's up to speed, gently lower it into place. See that little wobble? That's how much cutting it's going to do. And then we're going to follow our same path. So that's the idea behind how you start when your hole is getting pretty close. So we're going to go to about a 7/16 depth. Well, we might stop at 6/16 for now, and then we'll switch over to the other guide jig for the other hole. So yeah, I think we'll just do one more pass and then switch over the other jig. Alright, so we just got our first pass done on the secondary hole. I'm only going to do 2 passes on this guy. Now, the question becomes, how do we set the depth for the next cut? Well, so it gets a little tricky, but what you're going to need to do is loosen your tool, crank the depth down a little bit, and you need to go find the edge. See right there? I just found the edge that I just cut. That's not the top. It's not the bottom wall. It's you put a little bit of pressure on. Right there. That little click was it finding the right there. Okay? So that's how we set the depth of the next cut. As we go to the wall that we just cut, we very slowly put a tiny bit of pressure till it pops over. Lower the base, lock it in. We can double check that we seem to be at double the height on that guy. I suppose you could just break this thing and, you know, get the depth that way. But yeah, that's the intent. Right? It's kind of hard to find that edge and check. That's about where we want it, right there. Okay? We're not removing a lot of material, but we do need to be careful still. Alright, so after that 6th pass, we should be at about 6/16 in depth. And this 1/2-inch hole is getting real small. So we're really going to have to be gentle when we set this tool in. And we just got the recessed edge done, so that's looking good right over there. So I don't think we'll have any breakthroughs into the plate below, but we're just going to have to wait and see. And here we are. This is a finished product. So there's a couple imperfections, and we'll talk about that in a moment. But before we do, let me show you. So this is the copper oval. This might be a little tricky to do one-handed, but there she goes. These are 2 self-made parts. And I would say that's pretty darn good. So let me show you something before we talk more about it. As a consequence of this pressing process, this bottom is ever so slightly bowed. Okay, so when you put this guy in here, you can either clock it to one side or the other side on that bow. Ooh, that felt good. If that makes sense. So we'll take that not flat bottom out of that copper later, but for now, let's go over to that side, and let's go zoom in down there. All right, that's really good. That's barely a fingernail catcher. Oh, come on, stay focused. So that's really good. I'm really impressed with that. Now, so the wall thickness is a tiny bit thicker over here. So this guy has more of a fingernail catch in the middle there. But where it was stretched over there, it doesn't have as much of a catch. That could just be filed away after the fact. That's easy enough. Okay, so now that you get to see the the cool stuff, the good looking stuff, I'll show you the imperfections and talk about what we're going to do to fix it. So over here on this wall, come on, you can focus. You can see where the drill cut into the wall of the final part where it shouldn't have. Remember this one that I was worried about? Well, looks like I was right. So there's none of that on this back side. So I'm probably going to bring the drill bit holes in, probably about 10, 15, 20 thousandths, or probably about 20 thousandths. I don't know what happened there. I have no idea why that one got so out of whack. That's weird. Same with the one next to it. Because the 1/4 inch end mill did just fine. I might have just pushed too hard on the drill press and bowed the bit or something. So we're gonna suck those drill bit holes in. But given that we're gonna be dumping a ton of brazing compound in here to mate these two, like this guy, I have a feeling I'm just gonna dump some extra material into that little hole there. Here, we'll see what that looks like with the copper in place. Yeah, let's go zoom in. Alright, so I'll just dump some brazing compound in that hole and then just sand it flush. This whole inside is going to be sanded flush anyway after the brazing. Hey, how about that though? You can make accurate, very unique shapes with 3D printed tooling and wood tools. I like to call this method analog CNC because you're still using numeric control to get the shape you want, but you're doing it with a 3D printer, which is really accessible for most people. So, yeah. So all that's left is do this 5 more times. Anyway, I appreciate y'all watching, and I really hope this was helpful and informative, and I hope you get to learn some stuff here, and I would love to see anybody that replicates this process for their own project. So please let me know in the comments, link me to other videos, send me your projects. I'd love to see it. Alright, I think that's going to be it for today. Thank you all. See you later. Bye.